Howdy, welcome back to Multar Aviation. In this weather video, we're going to learn more about clouds than you ever thought possible. So hey, I'm Dr. Andy Multar. I'm a flight instructor at CFI IIMEI. I used to be a corporate pilot, and now I'm a professor of aviation. And so in this video, we're going to discuss what clouds are, the cloud levels, and the different cloud types within those levels. And everything we're discussing in this video is going to be in the Aviation Weather Handbook, which I provide a link for you here. So if you don't already own the Aviation Weather Handbook, I suggest you get it. Everything you need to know about aviation weather is in this book. It's a great book. There's other, booksellers out there that have their own aviation meteorology books, but this one truly, I think, is the best. So a cloud is a visible aggregate of minute water droplets and or ice particles in the atmosphere above the Earth's surface. And so, whenever you're looking at pictures of like water vapor, clouds, all that stuff, they typically like to identify water vapor with the picture of a cloud. But I want to make sure you understand water vapor is a gas. You cannot see it. And so, if it's a hot day, it's humid, you feel the moisture, but you don't see anything, that's water vapor. Clouds are actual liquid water, kind of like in your water bottle. And so all it is, though, is just tiny little water droplets that are all next to each other. And they're so light that they're lighter than the air below it. And so they kind of sit on top of that heavier air below it. And so water vapor, it's a gas. Clouds, liquid. Now, fog is similar to a cloud. I mean, it is a cloud. It just happens to be located on the ground. Now, some books, they like to describe fog as, within 50 feet of the ground. I like to consider a cloud, or, I like to consider, a cloud that's above the ground to be a cloud and not fog. But sometimes they'll just call it, low fog instead of ground fog. But, I didn't write the Aviation Weather Handbook, so I don't get a say in it. But I like to think of fog is just a cloud on the ground. And so anytime you see a cloud, it indicates air motion. Uh, it will describe the type of stability. So we'll kind of learn later, but stratus clouds, they indicate stable air. Cumulus type clouds indicate unstable air. And then clouds are proof that there's moisture. Now, one thing I want to tell you about, as we go through this video, I'm going to be telling you about, the types of icing you can get when you go into these clouds and the turbulence you can expect. Now, anytime you fly through a cloud, you're going to experience turbulence. Now, the bigger the cloud is, the more turbulence it'll have. So if you're flying into a cumulonimbus cloud, which is a thunderstorm cloud, there's going to be a ton of turbulence. But if you're going through a really tiny, small cloud, the turbulence will be much less. One time I was flying and there's just the tiniest little cloud. You could see through it, and the length of the cloud was about the wingspan of my airplane. And so when we flew through it, I mean, it was just a bump. It wasn't anything serious, but I was just kind of surprised how the fact that there was turbulence in it. So no matter what kind of cloud you're flying through, there's going to be at least a little bit of turbulence. So clouds form in the atmosphere as a result of condensation of water vapor in rising currents of air. They also form by evaporation of the lowest layer of fog. So, fog was on the ground, the lowest layer of it evaporates, and now it's a cloud. Rising currents of air are necessary for the formation of vertically deep clouds that produce precipitation heavier than light intensity. And so here we have the different cloud types. We have stratiform clouds. We have cumuliform clouds. Anytime you see the word nimbus or nimbo, that means rain, basically. Cirriform, so these are going to be your high altitude clouds. And we have different families of clouds. So it just depends on your region as to how high these cloud families will be. But we have our low clouds from the surface to 6,500 feet AGL. We have our middle clouds from 6,500 to 23,000 feet AGL. And then we have our high clouds that'll be, from 16,500 to 40,000 feet AGL. And so we'll start with our high clouds. Those include cirrus, cirrocumulus, cirrostratus. These are typically thin and white in appearance, and they're composed almost entirely of ice crystals. So we don't have to worry about structural icing of our aircraft as we fly through a cirrus cloud because the moisture is already frozen, so it won't then freeze onto our leading edges of our wings and our tail. It'll just bounce off. So here we have cirrus clouds. So these are just, white, delicate filaments of white patches or narrow bands of cloud. They're, fibrous. And so, they're just there. No significant icing whatsoever. And you probably won't get any turbulence. Now, I mean, there'll always be a tiny little bit of turbulence, but I mean, it'll just be very minor. Then we have cirrocumulus clouds. So these are cirriform cloud type, appearing as a thin white patch, sheet, or layer of cloud without shading. And so, there's nothing too special about these. You can expect some turbulence and icing, but if you're flying that high, you're going to have any ice de-ice equipment. It won't be a big deal. You pick up any amount of icing, you just turn your any ice de-ice, and it goes away. Then we have cirrostratus. So this cloud type appears as a whitish veil, usually fibrous, but sometimes smooth. It may totally cover the sky and produce a halo, and it might be so thin and transparent as to render it nearly invisible, especially through haze or at night. And so, like I said, it covers the entire sky. You don't see it. The only way you see it is maybe at night. Uh, there's a ring of cloud around the moon, and that might be the only cloud you see in the sky. And another term for that is God's eye. And so it's just so thin that you can't see the rest of the cloud, but the light refracting from the moonlight refracts into that perfect circle around the moon. And so we have cirrostratus. They might be saying that this is cirrostratus right here, but maybe this is a really thin cirrostratus cloud, even though you don't see it. Hey, it's there. Then we have our middle clouds. So this is going to include altocumulus, altostratus, and nimbostratus. And they're composed primarily of water droplets. And those water droplets might be supercooled. And so if you don't know what supercooled water is, that is water that the temperature of the liquid water is below freezing, but it's still in a liquid state as opposed to being frozen solid like ice. And so, if you've ever had a water bottle in the behind your front seat of the car, and it's been winter, your car's been out all night, and you go to pick up that water bottle, well, you drink it, it's nice and cold, but maybe you shake it up a little bit and it turns into ice. Well, that is super cool water. And the way that it goes from a liquid state to a frozen state is either there's some kind of catalyst of energy that causes it to then turn into ice, or it needs some kind of condensation nuclei. And so condensation nuclei, that's something that the water adheres to, that maybe the water is so pure it doesn't have anything to freeze onto. And so once you introduce some like leading edge of a wing, for example, now that's a condensation nuclei that supercooled water can then freeze. And so that's, obviously something we want to avoid. So if you're flying through these middle clouds and the temperature is below freezing, some of those water droplets can be supercooled and create structural icing on the leading edge of your aircraft. And so here's what the altocumulus looks like. So it's just, broken up clouds. There might be some turbulence and small amount of icing. Another middle cloud I want to tell you about is the altocumulus lenticularis, also known as standing lenticular clouds. And so these are an orographic type of cloud. So you have to have mountains for these standing lenticular clouds to develop, and they're caused by wave motions in the atmosphere. They're frequently seen by mountainous or hilly areas. I have seen them without mountains, but you're more likely to see them around mountains. And so here they are. You got these lenticular clouds here. You got another one here. It's called a cap cloud. And so, we got to imagine that the wind is coming here from the right and it's blowing across to the left. That's forming these lenticular clouds. Now, these clouds are very smooth. They're lens shaped, or maybe you'll read it as almond shaped. And they look pretty. Now, when it comes to clouds, the prettier they look, the worse they typically are. And so, you have to think of this mountain as an airfoil. It's a very poorly designed airfoil. And so, as the air, flowing from the right side here, we call this the windward side, as it blows over the mountain, that air is going to stall out and cause a lot of turbulence. So, anytime you see any lenticular clouds, expect heavy turbulence and downdrafts. And downdrafts near a mountain, not good. So, Yeah, not good. All right, and the reason why these clouds develop, you got to think of Bernoulli's principle. So, what happens as air flows over an airfoil? Well, the pressure is going to decrease. So, we're going to have lower pressure above an airfoil, higher pressure below the airfoil. And anytime you have a decrease in pressure, you're also going to have a decrease in temperature. Now, you think a dew point, dew point is the temperature at which air must become cooled to reach saturation. And so that's what's happening here. The wind blows over the mountain and it's over this poorly designed airfoil, the mountain peak, and the pressure decreases as it goes faster, and so does the temperature, and it goes down to its dew point and creates visible moisture in the form of a lenticular cloud. And so, but once it passes the airfoil, well, then the pressure increases, the temperature increases, and now you don't have any visible moisture because now the temperature is going to be above the dew point. Now, the time that you really have to worry if you're flying around mountains is when the wind speed is 40 knots or more, because that's when you'll definitely get a lot of clear air turbulence or turbulence associated with these lenticular clouds. All right, so we also have our altostratus clouds. This cloud type is in the form of a gray or bluish, never white, sheet of a layer of striated, fibrous, or uniform appearance, and it very often covers the entire sky up to several thousand square miles, and it has parts thin enough to reveal the position of the sun, like so. And you can kind of, make the outline of the sun here, and so it's just, kind of dreary, not great, but it's not bad either. Stratus clouds indicate stable air, so it's a relatively okay day. Hopefully your visibility at the destination you're going to will be good, but you could fly through this if you're instrument rated. When you're flying through the altostratus clouds, you do have to worry about icing. The upper part is going to be made mostly of entirely ice crystals, but the middle part will be a mixture of ice crystals, snowflakes, and supercooled water droplets. And the lower part will be mostly entirely supercooled or just ordinary water droplets. So you won't expect too much turbulence, but icing is certainly possible. All right, next we have nimbostratus clouds. So nimbostratus clouds are a gray cloud layer and often dark. Precipitation will be in the form of falling rain, snow, ice pellets, but they do not include lightning, thunder, or hail. That'll be reserved for the cumulonimbus cloud that we'll talk about here in a little bit. And so these nimbostratus clouds, they'll be composed of just normal water droplets, but those water droplets could be super cooled. So we do have to worry about icing in a nimbostratus cloud. The base of nimbostratus clouds are difficult to define due to visibility attenuation. So basically, you just kind of look up, and you may not see a definite, bottom to those clouds. You just lose visibility as you look up into the nimbostratus cloud. And so the nimbostratus cloud is officially classified as a middle cloud, but it may extend into a very low stratus or stratocumulus level. And so these clouds produce little turbulence, but they can pose a serious icing problem for pilots if the temperature is below freezing. Can you fly in these if it's above freezing? Sure. I've done it. As you go through your flight training, at some point you're going to fly through a cloud, one of these nimbostratus clouds. You're going to get rain, and it's going to be pretty cool. Actually, it's like, oh, interesting, because you're going super fast, that water streaking across your windscreen. So it'll be quite an experience. And then we have our low clouds. So low clouds are going to be composed of water droplets, and the water droplets may be supercooled or ice crystals when the temperature is below freezing. So you just got to be, cognizant of that if you don't have any ice or de-ice capability and the temperature is below freezing. So our low clouds could include cumulus and towering cumulus clouds. These are the big white puffy clouds. They take the form of individual detached elements that are generally dense and possess sharp, non-fibrous outlines. They develop vertically, appearing as rising mounds, domes, or towers. The bases are dark, but the sunlit exterior are brilliantly white. And so here's a cumulus cloud. When you start working as a professional pilot, you're going to be flying around these cumulus clouds, and I cannot describe to you how beautiful those clouds are from the outside. The white, the light strikes the outside of the clouds, and like we said, they're brilliantly white, and you actually see like hues of pink, purple, and it's one of the most beautiful things you'll ever see in your life. So, study this aviation weather hard so that, you'll be very knowledgeable about aviation weather and you can one day become a professional pilot. And so these cumulus clouds can develop into towering cumulus clouds, and the towering cumulus clouds are going to be the first stage of a thunderstorm. And so there'll be very strong turbulence and icing if you fly into a turbulence or into a towering cumulus cloud. So it's something you definitely want to avoid. And so we have our cumulus cloud, and if it continues to develop, then we'll have our towering cumulus clouds that develop. And I think this is a pretty short towering cumulus. I mean, they can extend vertically quite considerably. All right, other low clouds include stratocumulus clouds. These are stratiform clouds that are rounded, roll-shaped, and they contain small water droplets, sometimes larger water droplets, small hail, and rarely they'll also include snowflakes. Ice crystals may be present, and these stratocumulus clouds can produce virga. So, virga, if you don't know what that is, we describe rain as liquid water droplets that reach the surface. But virga, that is liquid precipitation that evaporates before it reaches the surface. And so, if you fly through stratocumulus cloud, you can expect some turbulence, but more importantly, you can expect structural icing if the temperature is below freezing. And so these are what the stratocumulus clouds look like. Not quite stratus, not quite cumulus, stratocumulus. All right, then for our low clouds, we also have stratus clouds. So these are going to be a gray layer of clouds with a fairly uniform base. They don't usually produce precipitation, but when it does, then it's a nimbostratus cloud. It produces drizzle, ice crystals, snow grains. So there's not going to be that much turbulence. There'll still be a little bit, but we're more worried about icing if the temperature is below zero. And so it's a dreary day, and it's just stratus clouds up in the sky. We like sunshine, so go away. Okay. Another type of low cloud will be stratus fractus and or cumulus fractus. And so whenever you see these are always going to be present when there's worse weather around. And so these are just little shreds of clouds that are really low to the ground, maybe like 50 to 100 feet, maybe 200 feet above the ground, below the nimbostratus clouds, below the cumulonimbus clouds. So these are just like a type of scud cloud that develop, closer to the surface than the storm clouds. So nothing special about them. I'm not worried about flying through these clouds. I'm worried about flying through the cumulonimbus clouds that they'll be near. And I don't really feel like this picture does it justice. Just imagine right around here, that's the cumulonimbus cloud above these tiny little clouds. And if you next time you're out driving and there's like a thunderstorm or a bad storm, just look up. You might see some like tiny little clouds that are close to the ground moving relatively quickly. That's going to be your stratus fractus or the cumulus fractus clouds. All right, next we have our cumulonimbus clouds. So these are our thunderstorm clouds. Now in future videos, I'm going to be talking about thunderstorms. So make sure you subscribe. That way you get notified every time I come out with one of these videos. And so cumulonimbus clouds, they're exceptionally dense and vertically developed. They occur either as isolated clouds or as a line or wall of clouds with separated upper portions. The precipitation is often very heavy and always of a showery nature because it's a thunderstorm. And because it's a thunderstorm, what creates thunder? Lightning. So lightning will always be prominent in a thunderstorm, in a cumulonimbus cloud. So cumulonimbus clouds are composed of water droplets and ice crystals, and they contain large water droplets which become supercooled because of the drafts within a cumulonimbus cloud. You'll have updrafts and downdrafts. And when we talk about icing, typically you can expect water to be supercooled between 0 and negative 20 degrees Celsius. And they always tend to freeze when they get below negative 20 degrees Celsius. But in the cumulonimbus clouds, the updrafts are so strong that they shoot those water droplets up so high, so fast that the supercooled water droplets can get to as low as negative 40 degrees Celsius before they freeze and turn into hail. So, if there's a cumulonimbus cloud, you do not want to fly in those. You will definitely pick up structural icing, just not good. All other weather-related flying hazards will also be found in a cumulonimbus cloud, and I'll talk more about if in the thunderstorm video. So make sure you subscribe about what to do if you accidentally fly into a thunderstorm. And so this is a, cumulonimbus cloud. It doesn't have the anvil on top, but yeah, you see that? Don't fly into it. And then here we do have the cumulonimbus cloud with an anvil. And there's no preference as to which one you don't want to fly into. You don't want to fly into any thunderstorm. And so the reason why it has the anvil is you have this wind here from the left that's blowing towards the right, and it's blowing the cloud at the very top, causing it to have that anvil. So that's why thunderstorm clouds will eventually develop the anvil on top. Now there's one cloud type I want to tell you about. It's called the cumulus mammatus. This cloud is not described in the Aviation Weather Handbook, but I think it's really important that you know about it. And so this forms in the most unstable of cumulonimbus clouds. And like I said, cumulonimbus clouds, they indicate unstable air. But this cumulus mammatus will form when it's the most unstable. And so it's formed by turbulence within the cumulonimbus cloud, and it indicates a strong chance of hail, heavy rain, and lightning in the vicinity. So if you see this, don't fly in it. And this is what it looks like. These bulbous shapes, memories. That's why they call it cumulus mamma. It just, these cumulonimbus clouds should have a flat bottom, but when it develops this shape right here, that is a good sign. Whoa, that's bad. It looks cool from the ground, but if you're up in the air in an airplane, yeah, not cool. So get away from there. So let's do a little review. What are clouds? Can you describe them? What do the presence of clouds indicate? And what are the different cloud levels? Remember, what was it? Low, middle, high. And what are the different cloud forms? And so make sure you subscribe. That way you get notified every time I come out with one of these videos, because we're gonna keep going. All right. Well, thanks for watching. Bye.